Before the panel, we have one more speaker, and it's from our host company this evening, Offis Cloud Services. So if you would please welcome Greg Steele to the lectern. Thank you very much.
Thanks, everyone. Okay, so I'm a solution architect, which means a couple of things. Firstly, it means I can crap on endlessly, as a few people in the room will attest. I'll try and control myself a little bit tonight. The second thing is that I spend most of my time trying to solve pretty complex problems. And one of the most complex problems I was thrown a couple of years ago was the need for a big organisation I was working at the time was really getting killed in its attempts to do DevOps or any sort of continuous integration or continuous delivery by environments. So you're all probably pretty familiar with the problems you have with the environments. We tend to need a whole lot of infrastructure to run our applications on. We're great at developing software applications. We're great at pushing them through lots of different test cycles. But we really, really rely on those environments being predictable and being robust and giving us the outcomes that we want. And that's something that we're terribly, terribly bad at today. We tend to treat our environments and manage our environments really the way we used to do software 20 years ago. So the approach I took to resolving what we're doing with environments was to take a total automation approach and start treating environments and start treating infrastructure, operating systems, platforms, configuration of platforms and systems, exactly the same way I treat software. So I can bring everything back to a set of automation collateral and then build an environment on demand that gives me the outcomes that I need in exactly the same way I can with software, and then deliver that progressively through my cycle. We see this as the most important enabler of DevOps, and it's one area that Offis brings most of its strength to this DevOps story, and its ability to use progressive capabilities, progressive tools, and use the cloud to be able to deliver automation of your infrastructure environments. So, why do we do it and how do we do it? This is one view of why we do it. The different stakeholders involved in your software delivery lifecycle, right? Your developer and project manager, from their perspective, when they're developing software, they want somewhere that they can test that software. And they want that environment immediately. They want it right at the start of the project. They want it to represent a specific state of their software, a specific baseline that they can work against. They want it to be stable. They don't want anyone else to play with that environment for the time that they're using it. When they finish their work, when they've got their features working, then they want to get rid of that environment. They don't want to be paying 3 years for having used an environment, a set of infrastructure for a week. When I'm talking about environment, I'm talking about everything. I'm talking about the networks underlying your infrastructure, the servers running on that, the operating systems, the configuration of the operating systems, the middleware platforms, all of those things that are necessary to have in place and have integrated so you can deploy your application. So that's what a developer or project manager needs. Other important people in your release cycle are your release manager. The person who's then got to make decisions about which features are going out in which release. Okay, what's tested, what's quality, what's proven, what can be merged together. It's got all that sort of baseline management responsibility. What is the state of all my code? What are my different applications? Which versions of which do I deal with? Which libraries am I integrating? So the release manager has a different need for environments. Again, they need to be able to pull together many changes, deploy them somewhere and test them in a fully integrated mode and run acceptance tests and have a whole bunch of end-to-end capability. And know that when they've merged a bunch of different features together, that new baseline completely works. The environment manager needs the ability to service the requests of all these people, okay? Needs the ability to, from a request from a project manager or a release manager or a test manager to say, give me the environment that's in this particular state, it's got these particular features, maybe it's production-like, maybe it's got, maybe it's a lower level of non-functional capability suitable for development, needs the ability to deliver that environment. To know what environments are out there, know what state they're in, know that they're being used appropriately, know, most importantly, who's paying for them. So what's the cost of running this environment, and be able to give that to somebody. Now, with our traditional methods of managing environments, we tend to make these long-lived, very expensive, very difficult to manage environments that we generally tend to have to share across different project teams or different feature teams. This makes it very difficult to know what's the real cost of that environment, what's the real value of it to a particular project. Most importantly, they're expensive and heavyweight to manage and maintain. Moving to a model of on-demand delivery of environments, of cheap environments that can be stood up within hours, that give you the ability to run an end-to-end set of integrated systems, means that you can start then focusing on your software delivery and software development delivery and a lot less on environments. So, lastly, your test manager obviously needs to be able to get a set of environments to work with. We've talked a lot about the importance of automated testing and automated processes to DevOps and continuous delivery. One of the things we do a lot of is we spend a lot of money on building automated tests. If I run a full suite of automated tests, the likelihood that they're all going to work is actually pretty low. I'm generally going to get a few failures. And then I've got to get some people to spend some time going through those failures and find out what went wrong. Now, in my experience, 9 times out of 10, the reason a set of automated tests fails is because something changed with the environment. Someone applied a patch, some other project team changed something in your environment, some data changed. All of these things can then cause your automated test to fail. And you've got 2 things you can do then. One is you can go back and fix that problem and rerun your tests. And you normally do, the best behaviour would be to. But really what normally happens, what I see more frequently, is that test gets turned off. That test becomes an embargoment in itself because it stops your development cycle. And you know, it's not a software defect, it's just something breaking with the environment. So we start turning off our automated tests. And everywhere I've been, there's a great wave of investment in automated testing, and then there's a gradual removal of those automated tests. We see the need to have a stable, deterministic environment that represents exactly the baseline you want to be testing against, and nothing else is critical to be able to get value out of automated tests. Once you can do automated tests, you can do continuous delivery. Okay? If you can't do automated tests, and if you can't sustain your level of automated testing, you're not going to do continuous delivery very well, or you're going to carry way too much risk into production. So for all of these reasons, we need to be able to create environments quickly, cheaply, run them for the time we need to run them, know exactly what state they're in, know what baseline they're built against, and then be able to dispose of them quickly. That takes a lot of automation. That takes a lot of capability. And it's something that's been really impossible to do with infrastructure in the past. With cloud, it becomes possible. So when people talk about cloud, people talk about moving or transforming or migrating to cloud. There's a whole bunch of reasons for that. Not many of them really actually stand up to a business case. The thing that's really important about cloud is it enables automation. And automation is the reason to change what you do. Automation allows you to then start serving all of these stakeholders, and a lot of these stakeholders are represented by the ISVs in the room, to serve these stakeholders better. Okay? So, how do we do it? This is my last slide, so I'll crap on about this one for a fair while, and please interrupt me if you've got any questions. There's a lot of information, a lot of thought goes into this, but what we do, and this is really about starting to treat infrastructure as code, is we take everything that defines what an environment looks like, and that's everything from your bare network upwards, right? We take all of the information and codify it, so use automation tools. Tools like Puppet and Chef, scripts, all sorts of different tools for different layers of your technology, and we codify what we need to do to be able to provision that, to build that, to integrate that and configure that. Now that means a whole lot of different collateral, right? I'm not talking about your source code here. From an application perspective, it's the version of an application and the artifact that you're deploying to an environment is important. From an operating system perspective, it's the image you're deploying and what standard operating environment you might be applying to that image and how you might be configuring that operating system to work for a particular application or a particular middleware platform. So all of that collateral, all of your installers, your configuration tools, your deployment tools, all of the things that we today have thousands of infrastructure technology experts go and manually do the same thing over and over again across all of our companies and environment to make these environments work for us. All of those tasks and activities can be turned into code. I've been doing this for a while at a big insurance company, and we're talking about 40 or 50 major applications and really complex integrations between them, including a mainframe that runs on a mainframe emulation platform in the cloud. So the degree of complexity that you can deal with through automation is pretty extreme. You come across very few things that you can't actually automate. You don't need to go re-architecting your applications to be able to do automation. So you bring all of your collateral back to somewhere where it's managed and maintained and controlled. What that means is all of your IP, everything that's important to you about the way your software runs is brought back to source code control. Okay, and when it's in source code control and everything's versioned and baseline, then you can start managing to a baseline. You can start managing your infrastructure to a baseline the same way you can with software. You can branch, you can merge, you can progress on, you can wind back. Right, a whole bunch of different tools are necessary to do that. We put a lot of stuff in source code tools like Git or Subversion. Your cloud management platforms actually play a progressively increasing role in maintaining and managing infrastructure configuration collateral. Offis is partnered with RightScale, and RightScale is a great tool for being able to capture definition information about what it is you're going to build. Right, then you need a factory where you can manufacture stuff. Given all of that information, all under complete control, the ability to then go and build me one of those environments so that I can then use is really critical. That manufacturing step needs to be fast and cheap and robust and give you the same outcome every time. Okay, it's only by turning your manufacturing process into something that's cheap to do that you can, and instantaneous to do, that you can start changing the way you actually look at these environments and make them disposable. So, you build yourself an environment that can be used for a particular activity. There might be differences between your activities. Development's a bit different from integrated system testing, which is a bit different from production. But essentially, the roles and profiles of the different nodes that you're building within an environment are pretty consistent. So you can apply the same techniques right throughout your delivery pipeline. So again, when Mridul's talking about the need to be able to do things repetitively and robustly, so you're minimising that risk that when you go into production, you know it's going to work. Okay, so if you're using the same manufacturing process for all of your environments, for all of your activities, then you're giving yourself certainty that what you develop and test and the way you run it and that entire technology stack that works at development and test time is also going to work in production. And then most importantly, once you're done with that activity, once you don't need that environment before, or when you're going to upgrade your production systems to the next version, what you had before is no longer of value, so you can dispose of it. Cloud allows us to use on-demand pricing models which allow us to dispose of stuff, okay, and not get sucked into a long-term CapEx to stand something up that you might need for an uncertain time. And lastly, most importantly, the way we then do everything is through automation. So we no longer have someone get onto a server and go and apply a patch. We no longer have someone log in and deploy a new version of application. These manual tasks we remove entirely from our thinking. The way we fix things, the way we upgrade things is by automation. We go back to our automation collateral, just like we do with software. We wouldn't dream of getting onto a web application and go and manually hack a jar file or a class to make it work differently. We don't dream of those things with software. We do it all the time with infrastructure. Treating infrastructure as code means we stop doing that. We go back to our source, we modify our source, we change the specification of that server to say it's going to have this patch on it now, and then we go and rebuild that server, right? So we do everything through automation. Allows us to bring all of our skills and knowledge about infrastructure back to this source code management view. So all of our IP, all of our knowledge goes into automation, but our delivery and implementation can then be done by less skilled people at the press of a button and in all sorts of different contexts. Right, that's me done.
Thank you very much, Greg Steele of Offis.